Hi friends, welcome back to the series of organic lectures on fundamentals of organic chemistry. Today I am going to teach about electronic displacement. We know that electronic displacement is a factor or is an effect where electrons are displaced in organic molecules. This is of two types. One is permanent effect and second one is temporary effect. Today in this video we are going to learn about a permanent effect of inductive effect, which is a permanent effect. Dear friends, permanent effect is an effect where even in absence of any reagent or a reactant or other reaction factors, this effect is observed. That is why this is known as a permanent effect. Permanent effects are three commonly observed in organic molecules. One is inductive effect, which is a permanent effect. Second one is mesomeric effect, and third one is hyperconjugation. And the second category of effect is a temporary effect. Under this, inductomeric effect is a temporary effect, and second category is electromeric effect, or the effect electromeric effect and inductomeric effects are temporarily observed. That means these effects are observed only in presence of a reagent or a reaction parameters. Today we are going to learn in detail about inductive effect. Yes, what is inductive effect? What is inductive effect? Inductive effect is an effect where partial polarization of electrons of sigma bond towards more electronegative atom. That means inductive effect is an effect where partial polarization of electrons takes place towards more electronegative atom in sigma bonded molecules. So what are the characteristics of this effect? Yes, there are mainly 6 characteristics observed in this inductive effect. What is the first one? Yes, just now we said that it is a permanent effect. It is a permanent effect. And one more important thing is it is operated only in sigma bonds. Only in sigma bonds. It is very important that this inductive effect is observed in only sigma bonds. In inductive effect, only sigma electrons are involved. What are the electrons involved in this inductive effect? In inductive effect, only sigma bonded electrons are involved. What happens in inductive effect? So in inductive effect, partial polarization of electrons takes place. For example, if we take alkyl halide or methyl chloride, in between carbon and chlorine, we know that chlorine is more electronegative atom when compared to carbon. That is why chlorine pulls the electron density or the electrons forming the sigma bond, it pulls towards its, so that a partial negative charge is observed on chlorine. At the same time, a partial positive charge is observed on carbon. Dear friends, in inductive effect, electrons are partially displaced so that the negative charge or the positive charge attained is shared. That is, more electron negative atom attains negative charge and the atom which is less electronegative is attains positive charge. and it is transmitted along the chain. For example, if we take, instead of methyl chloride, if we take butyl chloride, where this negative effect is observed along the chain, that means the first carbon which is directly attached to the chlorine will have positive charge more when compared to the second carbon, when compared to third carbon, and when compared to fourth carbon. That means as length of the chain increases, the inductive effect decreases. So it is clear, friends, nothing to worry. There are 6 factors which are there are 6 characteristics of inductive effect. It is a permanent effect. It is observed in sigma bonded atoms only, and only sigma bonded electrons are involved. And fourth point is, in inductive effect, electrons are partially displaced. See, in bond methyl chloride there is no break of bond, but there is no break of bond, but chlorine attains a partial negative charge and methyl attains a partial positive charge, and inductive effect is transmitted along the chain. As length of the chain increases, the inductive effect decreases. Let us see what are the negative inductive affecting groups. Negative means what are the groups which pulls the electrons in sigma bonded atoms. Yes, the atoms which are more electronegative than carbon are the atoms which pulls the electrons, especially halogens. What are the elements commonly elements commonly observed in organic molecules? Halogens, and oxygen and nitrogen containing groups. That means halogens are more electronegative than carbon. So fluorine, chlorine, bromine, iodide obviously pulls the electron density, and they feel a partial negative charge on them. And oxygen and nitrogen also more electronegative than carbon, so that the compounds which are having oxygen and nitrogen, like alcohols, ethers, amines, aldehydes, esters, carboxylates, acyl chloride, amides, acyl anhydrides, and all these are negative inductive affecting groups. That means they pull the electron density towards them. And moreover, NO2 nitro group and nitrile CN group, these are the two groups which are highly inductive affecting groups, which pulls the electron density of sigma bond. And what are the positive affecting groups? So positive affecting groups or positive inductive groups are very few, especially alkyl groups, methyl, dimethyl, trimethyl groups. These are the groups which affect or which show the positive inductive effect on organic molecules. And these are the two molecules where oxygen, which is carrying negative charge, is acting as a positive inductive group, and carboxylate ion also acts as a positive inductive affecting group. Let us see what are the applications of this inductive affecting group. So by knowing the inductive affecting groups, one can know, or one can establish, or one can differentiate the stability of alkyl carbocations. Applications of inductive effects are 3. One can assign the stability of carbocations, and one can differentiate the strength of acidity of carboxylic acids and strength of basicity of amines. Let us take stability of alkyl carbocations. As we know, tertiary carbocations are more stable when compared to secondary, compared to primary, compared to methyl. So why it is stable? Tertiary carbocation, like tertiary butyl carbocation, is more stable. But why? Yes, inductive affecting group of this methyl is giving a positive inducting effect where this positive charge is more on this carbon, so that it is more stable when compared to this secondary, primary and methyl carbocation. As the number of methyl increases, the stability increases, because the positive charge is shared by these methyl groups. The positive charge is shared by these methyl groups, so that the positive inductive affecting groups will increase the stability of carbocations. Positive inductive affecting groups increase the stability of carbocations. That is why tertiary butyl carbocation is more stable than secondary carbocation and primary and methyl carbocation. Similarly, what happens if a negative inductive affecting group is attached to a carbocation? What happens? Obviously, it decreases the stability of carbocation. For example, nitromethyl carbocation is less stable than methyl carbocation or ethyl carbocation. Ethyl carbocation is more stable when compared to nitromethyl carbocation, because nitromethyl carbocation is the cation which is attached to nitro group. Nitro group is a negative inductive affecting group where it already the carbon is lack of electrons, but it takes the electron pool toward this where it is unstable. That is why ethyl carbocation is more stable when compared to nitromethyl carbocation. This is very important, so that everywhere, like in all competitive exams, at the same time in all interviews, you may expect that which is more stable, that is ethyl carbocation or nitromethyl carbocation. Obviously, nitromethyl carbocation is less stable, but there is a chance of becoming or chance of mistaking everyone that nitromethyl carbocation may be more stable. Dear friend, be clear, because of negative inductive affecting group, this nitromethyl carbocation is less stable than ethyl carbocation. Clear? So, by knowing the inductive affecting groups, or the applications of inductive affecting groups are, one can say the stability of alkyl carbocations, so that if the carbocation is attached to positive inductive affecting groups, then the carbocation is more stable. When it is attached to negative inductive affecting groups, then the carbocation is less stable. Next factor is, or the application of inductive effect is, acidity of carboxylic acid. So how a carboxylic acid acts as an acid? Why? Because a carboxylic acid or COOH losing H plus ions, it becomes carboxylate ion, O minus ion. So among these two, carboxylic acid OH, COOH and COO minus, which is more stable? Do you know? Yes, because this carboxylate ion is more stable. Carboxylate ion is more stable than carboxylic acid. So to attain the stability, carboxylic acid loses H plus ions and it becomes carboxylate ion. That is why acids behaves or loses H plus ions easily, or releases H plus ions, so that it acts as an acid. Clear friends? It acts as an acid. So what happens? Inductive affecting group. So just now we observed that if the acid is attached to positive inducting affecting group, then the acid is less acidic when compared to the acid which is attached to negative inductive affecting group, that is chloro is a negative inductive affecting group which enhances the acidity of carboxylic acid. That means the acid which is attached to chlorine is more acidic than this simple acetic acid CH3COOH. Similarly, when you compare chloroacetic acid and acetic acid, which is more acidic? Chloroacetic acid is more acidic when compared to acetic acid. Similarly, as the number of negative inductive affecting groups increases, acidity increases. That means the negative charge on oxygen is shared by the negative groups, that is chlorine groups. That means trichloroacetic acid is more acidic than dichloroacetic acid than chloroacetic acid. When compared with in between fluoroacetic acid and chloroacetic acid, yes, we know that fluorine is more electronegative than chlorine, so the fluoroacetic acid is more acidic than chloroacetic acid. Let us take the effect of inductive affecting group in a chain where near to acid group, that is alpha to acid group, beta to acid group and gamma to acid group, what happens? Yes, as the inductive affecting group, especially negative inductive affecting group which is alpha to the carboxylic acid, is more acidic because the negative charge which is going to get after losing H plus ion is more stable because of this chlorine, and when the chlorine is away from this acid group is less stable, and when the chlorine is very far, that is gamma to the acid group, is also very less stable. So the alpha chlorobutyric acid is more acidic than beta chlorobutyric acid, then gamma chlorobutyric acid. Among these three, which is more acidic? This three compound alpha attached chloro compound is more acidic when compared to beta and gamma. Sorry. Let us compare what happens. So acetic acid, after losing H plus ions, the obtained carboxylate ion, the negative charge on oxygen is more on oxygen, so it is less stable. Whereas in chloroacetic acid, the carboxylate ion or O minus is stabilized by chlorine. The negative charge on oxygen is stabilized by chloride ion, so it is more stable. That is why it is more acidic than acetic acid. That means the inductive effect, which is positively inducting affecting group like methyl group, is attached to carboxylic acid, then the acidity decreases, or it decreases. Positive inductive affecting groups decreases the acidity of carboxylic acid. Let us take further examples where formic acid, yes, this is a formic acid which is not attached to any positive or negative inductive affecting groups. So this is highly, or this is the strongest acid among unsubstituted saturated monocarboxylic acid. So dear friends, remember this point: formic acid is the strongest acid among unsubstituted saturated monocarboxylic acids, that is acetic acid, propionic acid, butanoic acid, like. So homologous carboxylic acids, among the homologous carboxylic acids, formic acid is the strongest acid because acetic acid is attached to positive inductive affecting group, so it is less acidic than formic acid. And here there are two inductive affecting groups, that is methyl CH2 and methyl, so it is obviously less acidic than this. Oxalic acid, it's a carboxylic acid. Just now we saw this. This carboxylic acid is negative inductive affecting group, so the acid group which is attached to negative inductive affecting group is more acidic than the acid which is not attached to any group or a positive inductive affecting group, attached acid, that is acetic acid. And when you compare the acidity of oxalic acid and acetic acid, oxalic acid is stronger acid. And one more point, so in homologous acid groups, that is oxalic acid, malonic acid, succinic acid, glutaric acid, as you go further, oxalic acid is the strongest acid among unsubstituted saturated dicarboxylic acids. So fourth example, when you compare fluoroacetic acid and dichloroacetic acid, which is more acidic? Yes, you may say fluoroacetic acid is more acidic, but it is attached to two chloride ions. So this dichloroacetic acid is more acidic when compared to fluoroformic acid. Similarly, this is the acid, oxalic acid, and this is a salt of monocarboxylate salt of oxalic acid, which is more acidic. Yes, this is more acidic because there are two groups. In other way, we can say that this is having two H plus ions, so it is more acidic when compared to this, because it is already given one H plus, so it is less acidic than compared to oxalic acid. Dear friends, so 2 points, be clear. So formic acid is the strongest acid among all homologous acids in that series, and oxalic acid is the strongest acid in that series of homologous acids. Clear? Yes. What is the third application of inductive effect? Yes, basicity of amines. This is very important point, where especially when one compares methylamine, dimethylamine and ammonia, so which is more basic? Yes, so positive inductive affecting groups, as the number of positive inductive affecting groups increases, the basicity increases. That means a basicity means the amine which is attached to more positive inductive affecting group is easily capable to donate this lone pair of electrons, so that it acts as a base. So dimethylamine is more basic than methylamine and then ammonia. So one may have some doubt. Dear friends, be clear. Ammonia in gaseous form, it is more basic, but in organic reactions, or if you are performing a reaction in aqueous media, so ammonia is less basic than compared to dimethylamine and then compared to this. So basicity order of these amines is like this: dimethylamine is more basic than methylamine, then ammonia. So one may get another doubt. There is a trimethylamine amine also is there, trimethyl ammonia, trimethylamine. Dear friends, trimethylamine comes here. That means dimethylamine is more basic than methylamine, then trimethylamine. Why this trimethylamine is less basic than this dimethyl? Though it is trimethylamine is attached to 3 methyls. Dear friends, we will learn in detail about acidity and basicity of carboxylic acids and bases in next lecture. But here remember, because it is attached to 3 methyl groups, it is shielded. The lone pair electrons are shielded with this methyl group, so this amine is not able to share or donate freely of its lone pair electrons. That is why it is not that basic when compared to dimethyl and methylamine, but it is more basic than ammonia. As number of positive inductive affecting groups increases, the basicity increases. Yes. Similarly, as number of or negative inductive affecting groups, what happens? Decreases the basicity of amines. For example, methylamine and trifluoromethylamine, which is more basic? Yes, this methylamine is more basic. Dear friends, be clear, inductive effect is an effect where it is a permanent effect. It operated only on sigma bonds, and the atoms which are more electronegative than carbon will pull the negative charge of sigma bond and attains a partial negative charge and gives partial positive charge to carbon. And applications of inductive effect, one can say that stability of carbocations, acidity of carboxylic acids, and basicity of amines. So dear friends, so there are 3 questions where one can expect in all types of interviews, exams, and everywhere. So one is acidity order of methyl primary tertiary carbocations, stability of tertiary, secondary, and primary carbocations, and acidity order of formic acid, these acetic acid and propionic acid, and the basicity of dimethylamine, methylamine, and ammonia. It is clear, friends. In this lesson we learned about the inductive effect of organic molecules. Next video we are going to learn about mesomeric effect, which is also a permanent effect. Thank you for your time, and please subscribe my videos, or at least like my videos, or if you have any questions, please comment so that I can improve my next lectures. If you have any questions, please write it on comments so that I will answer your questions. Thank you. Bye. Take care. Enjoy. Bye. We will meet again very soon with a new lecture on mesomeric effect. Bye.